slides shows the penetration resistance test, or it can be said that drop cone test. Now, this method was to simulate stresses caused by falling a rock. The geotextile, the sample is clamped down in a circular ring clamp directly on a water surface. A pointed cone is dropped, puncturing the geotextile, and the diameter of the puncture is measured. The diameter of this puncture is measured with the help of a solid cone as it is shown here, and it also calibrated. This is the hole diameter in millimeter, and this is the inclined distance in centimeter from the tip. So, the advantage of this test method is that the geotextile interact with the soft base, that is water, and therefore yield more practical result than other test method. However, there is difficulty in establishing the exact diameter, since the most geotextile have an elastic range. A variation of this test method can be conducted by dropping a pyramid which better simulates very angular fill material. Now, in case of the hydraulic testing, that means water permeability of the geotextile by the permittivity. Now, this permittivity can be derived from permeability result. The permittivity is an indicator of the quantity of water that can passes through a geotextile in an isolated condition independent of the thickness of the geotextile. Now, the permittivity can be expressed as the psi is equal to Kn this divided by this T. Now, Kn is centimeter per second, that is permeability coefficient normal to the plane of the fabric, and T is the thickness of the geotextile. Now, relating to the Darcy's formula, that is Q is equal to K into I into A, we can write substituting that Q is equal to Q is equal to K into N into delta H divided by T into A. Now, if we rearrange this, we can Kn divided by T is equal to Q divided by delta H into A is equal to psi, where the Q is the flow rate, delta H is the head loss, and A is the area of fabric under test. So, from this test we can determine the permittivity of the geotextile material. There are the other test which is called the transmittivity. So, transmittivity testing is to measure the water flow capacity along the plane of the geotextile. The amount of water that will flow along the plane of the geotextile material is dependent on the thickness of the fabric, the permeability of the geotextile material, and the overburden pressure. Now, this transmittivity, which can be denoted as the theta, that is the length square divided by time. Theta is equal to Kp divided by T. Sorry, theta is equal to Kp into T. Now, this Kp is centimeter per second, that is permeability coefficient in the plane of the fabric, and T is the thickness of fabric. Relating to the Darcy's formula, that is Q is equal to K into I into A, and rearranging, then Q will be equal to Kp into delta H by L into W into T. Now we can write that Kp into T is equal to Q into L divided by delta H into W is equal to theta. Here Q is the flow rate, L is the length of the fabric, and delta H is the head loss, and W is the width of the fabrics. So from this test we can determine the permittivity of the geotextile material. There are some of the summary of the properties of the geosynthetics material, that it has an excellent the stress strain behavior, and geotextile material has good flexibility, and it has an excellent the filtering characteristics, high water permeability, excellent mechanical protection. It can be welded together, it does not form by product, it has a high resistance to climatic condition, and it has highly resistance to all chemical as well as biological attack, and it is chemically UV stabilized. Now this geosynthetics material has been internationally well established in the field of construction engineering for many years, especially in reference to the civil engineering. It has become solution to design and construction problem independent of the geographic, climatic or the technological differences. The uniqueness of geosynthetics are the simpler in their application and offer multi-functional performance while providing the important economical advantage. There is no other construction material available in the entire construction industry, be it concrete, steel or wood or any combination thereof, which offers such a variety of solution to construction problem as does the geosynthetics in civil engineering. Thank you. this topic is the potential of jute coir geotextile in civil engineering. This biodegradable nature jute and coir geotextile material has proven itself to act as an effective soil stabilizer in its various form as a fabrics or netting or a suitable assemblage depending upon its intended use. As a woven or non-woven fabrics, it can perform temporary reinforcing and permanent filtration and separation function for a subgrade. As a net, it can be applied in various design for erosion control purposes. In a prefabricated drain assembly, it has proven as an efficient means to consolidate deep-seated soft clays. Here an attempt has been brought out the potential of jute assembled soil stabilizer for various geotechnical application. As we know, here this transparency shows the wall production in jute and the allied product. This in India, Bangladesh and this China. See 1985, this 1992-93. The total production is 3065.5 ton. This world. In India is 1260. Now here is also we can see that estimated supply, domestic requirement and export in major producing country in India, Bangladesh, Nepal and this Thailand. This jute material also can be used in the erosion control. In some of the selected countries in USA, China, Nigeria, India, Belgium and England. It depends natural bare soil. You can see that some of the rate of erosion in the different countries. Similarly, you can see that area of coconut product in different state or the union territory and what should be the annual percentage of fiber product in tons. This that the state in Kerala Tamil Nadu, Karnataka, Andhra Pradesh, West Bengal, Odisha, Goa, Daman and Maharashtra, Andaman and Nicobar Island, Assam, Pondicherry, Lakshadweep and the Tripura. And some also estimated annual world output of the coconut from the different country, what should be their percentage of production to world total, and what should be the annual percentage of fiber product in tons. This is Philippines, Indonesia, India, Sri Lanka, Malaysia, Thailand, Fiji Island, Papua and New Guinea, Solomon Island and Western Samoa. This coir geotextile also has a lot of application in erosion control, and this chart shows the field trial using the coir geotextile in India, so in Australia and also in Germany and some other parts of the countries. Now this natural material, jute and coir, has a potential use in different areas in civil engineering. Some of them like drainage for the roads. It is either the subgrade drainage or the interceptor drainage. Now jute and coir, woven geotextile material, have been used for subgrade and the interceptor drainage in case of the road construction. When the subgrade is weak with a California bearing ratio is less than 3, jute and coir can be used to separate the subgrade from the subbase to serve as a dual purpose. It acts as a membrane and separator to spread the load over wider area, as well as the prevent subbase material punching into the softer subgrade. It acts as a membrane. The initial tensile strength of jute or coir can cope with such a requirement until it loses strength as biodegradation sets in. However, during a lapse or during a couple of month time lapse, the subgrade CBR would more than double due to consolidation that occurs under the pavement and the traffic loading. Now the consolidation is made possible due to the filtration and non-clogging properties of the jute or coir, which would permit only the subsoil pore water to exit, while not letting the fine from the soil to escape into the subbase. The loss of strength of jute or coir would therefore be compensated by the resultant gain in strength of the subgrade. The efficiency of the natural material as regard filtration and drainage does not diminish either with the strength or because of the biodegradation. Now, this in case of interceptor drainage. Now, interceptor drain consists of the shallow trench on either side of the road filled with graded aggregate filter with or without a perforated pipe. Such a drain is different and difficult to construct, as procuring and placing the graded filter pose problem. With a short span of its service life, the filter material would lose its efficiency because of the fine material entering and filling the parts of the whole of its voids. Such a situation would instigate moisture induced pavement distresses unless repairing are carried out promptly. Such repair occurs too frequently and are expensive. On the other hand, the durability treated woven that woven jute or coir is used to line the drainage trenches and encapsulated open graded aggregate. This would simplify construction and protect the aggregate from clogging. The jute, the liner, would effectively filter water and separate the surrounding soil from the aggregate in the drain. The use of perforated pipe is optional. The performance of jute or coir would last indefinitely despite the biodegradation. Now this natural material have a lot of application in erosion control. Now in case of the erosion control, because its biodegradability was an additional advantage. Initial erosion was resisted by the strength and subsequent membrane action. As the jute or the coir biodegraded, the roots of grass and vegetation reinforce the surface to protect the surface permanently from the wind erosion. By its water retention and biodegradable nature and its ability to promote vegetative growth, jute or coir geotextile application has been observed to be a assuring success. Now its ability to absorb water and to rot away fairly quickly are its desired properties. Secure with pegs of bamboo and wood, which are also environmentally acceptable. It is also seen from the laboratory that the soil losses in the case of jute was consistently very low, attesting to the superiority of jute and coir for erosion control application. Coconut geotextile also they perform equally well. Now attribution of the jute and coir for the erosion control. So jute should be used where vegetation is considered to be the long-term answer to the slope protection and erosion control. Jute as a slope protection and erosion control material has a number of inherent advantages. It gives protection against the rain plus erosion. It has a capacity to absorb up to 5 times its own weight of water. It has some additional storage capacity in its structure, which provides a series of mini dams. It reduces the velocity, and thus the erosive effect of overland flow. It maintains humidity in the soil and the atmosphere. It probably mitigate the extremes of the temperature. It protect against direct sun rays and the desiccation. It provide a sufficiently open structure not to inhibit plant growth. It provides an environmentally acceptable appearance. It biodegrades, adding useful fiber to the soil structure, and it is unlikely to present future problems for engineers, farmers, environmentalists, and the public in general. Now, this geotextile like jute and coir can also be applied to river bank erosion protection. And this is the river bank erosion protection. The jute was strong enough initially to perform function of membrane action and separation, and to resist and penetration of the wrap by puncture. Jute had lost about 70% of its strength over about an year of its service life. It stayed intact, performing into filtration function forever. The loss of strength of jute and therefore its inadequacy for puncture resistance was more than compensated by the steepening of the soil, which is supported due to consolidation effect. Why should use the jute for erosion control? Because jute and coir is environmentally sound. The natural material promotes the vegetative growth. They are economical, aesthetic, and add organic material to the soil. Jute and coir control the erosion, and jute and coir is easy to install, and jute and coir is versatile, and jute and coir is a proven performance. This natural material also can be used for the consolidation problem on the soft soil. The construction of building on soft clay soil lead to the long term settlement problem, which are best dealt with by pre-consolidating the clay soil until the anticipated settlement under the design load is enforced completely or partially prior to construction. Here, a type of the flexible jute prefabricated den known as fiber den, made out of jute fabric, suitable for consolidation of soft compressible soil, has been developed and field tested. The drain consists of a rectangular strip of 80 millimeter to 100 millimeter width and 8 millimeter to 10 millimeter thick, obtainable in the form of roll in length of 500 meter to thousands meter. The drain strip itself consists of 4 coconut coir fiber strands of 3 millimeter to 6 millimeter diameter, laid longitudinally parallel to each other and enveloped by 1 or 2 layer of jute fabric held together by longitudinal stitches. Now, here There are the important these properties of also this fiber drain, and such drain can be inserted